Welcome to the Artificial Intelligence Podcast with your host, Dr. Tony Huang. Today, I'm here with Nick. Nick, can you introduce yourself?
Yeah, hi. My name is Nick Vasiloglou. People usually know me as Nick the Greek. I'm from Greece. I'm the VP of Research ML at RelationalAI, and I'm based in Atlanta. I've taken the AI journey for the past 20 years, 25 years now, and I've seen a lot.
Very cool. In the past, what were some key trends that occurred? Like Gen AI is relatively new, but I'd say were you around back when neural networks were around? Can you give us some background on what happened back then and also any cool trends that you noticed that actually stuck until today?
Oh, yes, I've seen the movie from the beginning. I started with signal processing, which was Fourier transforms and the first time of statistical kind of learning. And then I did see the rise of the neural networks while I was an undergrad. I took courses. It was really impressive. And then when I started my PhD, the world of kernel methods. I don't want you, if you wanted to give you the whole timeline in kind of 60 seconds. So it was like support vector machines. It was this idea of kernel methods, shallow methods that dominated, had a big impact. And slowly back in 2006, I remember I've been attending NeurIPS, which is the biggest conference in AI for 38 years now, not from the beginning, but somewhere in the middle. And then graphical models. And at some point, the gradient boosted trees started dominating, which was, let's call it a hack of machine learning if we want, because it wasn't as, I don't say, there wasn't that much theory around it as it was for other methods. But it completely exploded with Kaggle, and it showed a lot of value. And very slowly, there was a trend back in 2006 for about 6 years. The deep learning revolution was heating up again, and then it popped back in 2011, 2012 with the famous YouTube cuts and the ImageNet. And then I think the rest is known to the people. Of course, there's another pivotal moment in teen with a transformer and then ChatGPT, and then where we are here. But I think deep learning, once it came back, it had a pretty steady, aggressive growth. So it never stopped. And probably it hasn't.
Yeah, back in 2017, that was like a big year for everybody where Transformers really took off. I think I'd say like last year to a year and a half from now, there was a big movement in RAG. Can you describe what RAG is and then why it's important to the Gen AI movement?
Yeah, the number one application in AI in general is the chatbot, a question answering, let's put it that way. So that was a well-formed problem for many years. It's just that the systems were not really that great. And even until ChatGPT or GPT 3.5, there were a lot of complicated systems and the performance wasn't that great. But if you think about it, if the race for artificial intelligence is to emulate humans like as assistants in the beginning, a human is very good at, you ask questions, you get answers. And RAG is like the simplest form of doing that. Once the language models came out, which we had the two modes. One was the external and the internal. One you're asking, and you assume that the language model has seen that in pre-training. And the other was, okay, if I give you the context, can you find the answer? And that, of course, took off because it was the only way you could scale, let's say, 3 or 4 years ago. And I think it still is. And yeah, I was fortunate enough to leave that wave from the beginning because we did the first commercial deployment of one of the biggest vector databases then, Pinecone. It was called Hypercube. And we saw the potential early on, and that took off.
Yeah, I'm about to say the internal knowledge or like the world knowledge that a lot of these large language models has, it does have a chance of hallucinations. Can you go over what hallucination is and what that is in context with Gen AI?
Yes. So I think I'm not a big fan of the term hallucinations. I think the term is going to go, or maybe will stay for historical reasons, because if you if you think about us humans, we learn so much information, we try to tidy up in our brain, and at some point we start making mistakes. Maybe I thought that it was you who I met 3 summers ago or 5 summers ago. It could have been you, but maybe it was, I don't know, your brother or your sister or somebody else who, in my mind, think similar. It's interesting because hallucinations are not things that they're completely insane. They're things that they could have happened, and there's often a semantic similarity. So if you're asking about if Alexander the Great can say he was born in Athens, he was born in Macedonia, which they won't say he was born in Italy or he was born in Sweden. So it's interesting. And I think now we're becoming much better at managing hallucinations. We try to put a lot of external guardrails and verification systems to get to that. But I believe over time, as we build bigger and better language models, that is going to go away. Now, it's a big bet over there, but I feel like the language models do not have the sophistications that humans have in order to avoid hallucinations yet. But yeah, it is a problem when you are trying to build applications that they require 100% accuracy, or anything that happens and says the wrong thing would cause a big issue.
So what are some like tips and tricks to get the system to output near perfect like information, or is that kind of like still in the works right now? Like I can imagine people in like the healthcare field or something like that requiring like the exact correct information at all times from a chatbot. Like how would like someone go about to guarantee that the info is correct?
Yeah, there are ways to reduce it, but not eliminate it. There are fact-checking systems, like a mini check is one of them. It's basically language models trained to answer whether the result is consistent with the evidence. In some cases, you have verifiers that they can take the facts and check them back. No, it's not always possible. For example, when you're trying to find a mathematical proof with a language model, in fact, the fact that it hallucinates is good because it can go in different directions. But in the end, you have a way to say whether this thing is correct or not. Or if you have a language model trying to find you a path very quickly from point A to point B, it can make mistakes, but you have a way to go back to them up and say, hey, that's not right. So that's one of the ways that people do reduce the hallucination. Of course, GraphRag was one way, that another direction that people are taking. But I want to say my favorite one is doing things offline. It's something that we forget. But in machine learning, we love the automation, but we underestimate the number of human annotating effort or checking effort that goes to huge system like even OpenAI or Google for people tuning and verifying things. The best thing you can do is, if you have a question answering system and you want to be accurate, use your language model to generate as many questions and answers as you can, and then slowly curate them in the back end. And some of them you can curate them even automatically, or you can use some humans in the loop, and try to always anchor to that when people ask you questions and answers. So have a safe set to refer to.
Yeah, but isn't that more like expensive though? They'll just hire a bunch of people to manually review all that as a feedback loop.
What's interesting, there's a book called Ghost Work, which I highly recommend, where it shows you that was before the era of language models, but it was actually during the era of the tech boom in the Silicon Valley. People were ignorant about how much work is going to human annotators. If you think about companies like Scale AI, huge valuations. And if you see the balance sheets of companies like Google and Facebook and YouTube, yes, you see a lot of money going on. But even some of them, you can have with high confidence. So you can verify them with high confidence semi-automatically or with another language model. There's tricks. I don't want to go into the details, but if you want to be 100%, you have to have humans look back to them. But if you can even allow a small error, you can use some language model. But you always have, what I like about this option is that if something goes back, your users can give feedback and say this is wrong. You can go back and remove the question, toss it out, and the answer, or check it. So it helps you create slowly some ground truth, okay, which is equivalent to what people are doing. Another way of doing that is slowly building a knowledge graph. Okay, so you can start in a semi-automated way, and then you can have parts of your applications that they are not mission critical, and people have the opportunity to fix errors. and then use that to feed the mission critical. Let me give you an example. Google Maps. Google Maps has a lot of mistakes. How do they fix them? People always submit feedback. And they do have a lot of annotators going through and checking things. Okay. And then if you have a self-driving car that needs to have 100% accurate information, you use the parts that have been validated by humans. You maybe say that car doesn't go in that area because we haven't checked it yet.
So what's going on right now in the world? Are people switching from RAG to something else? I did hear like graph RAG is a big hot thing now. Can you describe what graph RAG is and how that's different from your traditional RAG?
Yes. So last December, I attended the latest NeurIPS. You will hear me talking a lot about this conference because this is a conference that brought us Turing Awards and Nobel Awards in AI. And this is like where the best and the hottest research is coming. So I spent hundreds of hours going through the content. And if there's one emerging trend, there's about 12. I'm going to release my full presentation on that soon. One is the agentic systems. Okay. Now, GraphRag, in a way, you can think about that as a specialized agentic system. I code a paper from, I think it's from Google DeepMind. I don't know if it's Google Brain, Google DeepMind, they're the same right now, where they basically do something similar with GraphRag, but they deploy more agents. In a sense, it is solving a search problem, okay? And the search problem is to answer a question. A search problem could be provide the mathematical proof, okay? People are using agents more and more. Systems like AutoGen, LlamaIndex, LangChain, complicated systems that they think a lot in order to give an answer.
Yeah, I think this is my own personal opinion, but I think all roads lead to graph RAG at the end of the day. Because honestly, I think that's the only way, the only current way that I see fixing all of our issues that like your traditional RAG can't fix, right?
It
Um,
is. And it is because it's the most practical. One of the problems with there is agentic systems that they can design a new drug, but they take days of conversational work and a lot of capacity. When you are talking about question answering and assistance and things in the enterprise, you need something that is going to respond maybe in a few seconds, maybe a minute maximum. And GraphRag, it's like the best we have that solves the neurosymbolic AI, something that has the generalization of neural networks, but the accuracy and the speed of symbolic AI. So it's like the best breed. We also have the technology. We have fast and scalable graph databases. Also, I think it ties really well with the trend that we see in the industry, because you have to see the other side. What does the modern enterprise use? They use the data cloud. Okay, so they do have the data in big relational databases, and we see that in order to be able to manage them, they have to resort to solutions like semantic layers. Another way to think about that, ontologies or knowledge graph. You can see the valuation of Palantir, $240 billion. It's all about doing this extra legwork, and that ties really well with GraphRag. I've been in the business of knowledge graphs for many years, and one of the problems we had was we knew that you can modernize an application by having, like, if you have a knowledge graph, you can really tidy up your company, it can be very efficient, you can write better software. The problem was that people would say, I don't have a knowledge graph. And they would say, what would it take to build one? And you had to do it manually, and you would start with a POC of $1 million, and people say, hey, I don't want to spend $1 million before I see the results. Or they would do something small with some manual construction. But now it's not only that language models help you automate parts of that process and build it at a much lower cost. It's also that you have an immediate application, which can bring, but you can see value, which is the question answering. So GraphRag, it's a good segue that leads the company to start building knowledge graphs, improving them, and then applying them everywhere in their organization. So yes, I see a lot of positive things coming out of that.
yeah, I've spoken to a lot of companies that when they start off in their AI journey, that they go with a really basic RAG system. So they'll go with like Pinecone as their vector
Mm-hmm.
database, and then they'll use LangChain to connect everything, and then they'll connect it with they'll use like OpenAI for the language model, and they'll find out that after 2, 3 months worth of like playing around that when they try to put it into production, it's either really expensive or it just doesn't do what they thought it was going to do, and then or it just breaks because LangChain breaks randomly. So a lot of folks like that I know, they've switched over to a Postgres database, and then they try to build like a RAG system from that, and then they moved away from like LangChain and they try to like hard code everything. And then they also got a lot more adventurous and moved away from like OpenAI, went to Anthropic or like Metas Llama or something open source or like DeepSeek, for instance. And now seeing a lot of folks get to that stage and then they'll go into the graph rag. It'll be like graph rag curious. Is that what you're seeing right now as well in terms of that kind of that trajectory where like they're using these, I guess, like best scenario like starter set like the LangChain, Pinecone, OpenAI, and then they'll move on to building their own rag. And then they'll see like their traditional rag doesn't really work that well, and then they'll try to move on to like graph rag. Is that kind of what you're seeing in with your clients?
So I've approached the problem from two different ways. We, as relational AI, we're a Snowflake native app. And I can tell you that what I've seen from the customers is the customers want to build everything in one place. Okay, like the customers that we deal with, they want everything to be on Snowflake and they don't want their data to move around. That's like a big problem with the enterprise. And we realized that Snowflake offers everything we need. From the vector database, we are the graph database. They offer Cortex that has, even Anthropic is running right now on Snowflake. Okay. And so we can have, it's a big selling point, having everything living in the database. And then when it comes to the implementation, which by the way, we have a guide if you want to build it on your own on Snowflake, but we also build a more complete approach because there's a lot of engineering details to make this run end to end. It really depends. Some companies that want to have full ownership, others that just want a turnkey solution. I've seen the following stuff. Yes, when you work with GraphRag, what is GraphRag? Basically, GraphRag finds documents eventually and information that can be in completely different places and put them together so that you can get a great answer, big answer. The other thing is sometimes you do have documents and you ingest them inside a database so you can actually query them with SQL. Okay, and the role of GraphRag is literally taking the natural language question and converting to SQL. So that's one part. But even if you want to get the answer from the documents, GraphRag gives you this opportunity to think, how do I want to combine my information so things that they are relevant come close? And you got the traditional Microsoft approach where they do community detection. We also use paths. I have this demo query that I ask people, if you wanted to buy a NASDAQ stock to help Rwanda, which stock could that be? Okay. And if you think about it, there is a reasoning path from Microsoft, NASDAQ, Microsoft, Bill Gates Foundation, malaria, Rwanda. Okay. That's something that if you don't have that written in a document, you would never be able to find. Now, is that the nature of your questions? Maybe not. It might be that your questions require some kind of triangulation. So you want to go to your knowledge graph and try to find triangles or other types of patterns. So we're trying to give this option to the users to decide what they need. The other thing that I've realized with the customers are very, as you mentioned before, serious about inference costs. Okay. And I've been with customers where they say, we like a RAG, but every time we send 5,000 or 10,000 tokens to OpenAI, we get charged for 10,000 tokens. And if you and I ask the same question or a similar question, if it's similar, it means I can't really cache it. If it's not exactly the same, I can cache it. But if it's similar, it means that I have to send more or less the same chunks to RAG. And people don't like that. And that's where we bring fine tuning into the table. We're basically, after we do a lot of pre-processing in the beginning, then we fine tune models. We generate questions and answers and fine tune. And that helps with latency. Also, you can have smaller models, reduces the cost. And this final thing, what people really love is the fact that the whole application is built on Snowflake, which means all the intermediate steps are in Snowflake tables. And again, I'm saying Snowflake, you can pick Databricks or other ecosystems, data clouds. It could be on Google Cloud because they also offer similar solutions. Is that everything is auditable and you can reuse them in other applications. You see transparently everything that is happening.
In your opinion, what are some limitations on using a knowledge base, such as graph rag or just rag?
In my opinion, the biggest challenge is the representation of knowledge. First of all, doing the extraction properly and in a way that doesn't have a lot of errors. Because once you get an error in your knowledge graph, it's going to propagate and stay there forever. And the initial form of GraphHack was with triples, subject, predicate, object, which is a good start, but it's quite problematic because it fails to capture timestamps and other qualifiers. I think, and I spent a lot of time trying to find the best representation, and I ended up using what other researchers have, have found, which is, if you think the best or the biggest knowledge graph we have is Wikidata. Okay, so you go from Wikipedia to the, and I like the meta model, their schema, which it's about 4 or 5 tables. It's not very, very big. And so when the customer comes and they don't have a specific, very restricted ontology and it's quite open, I like using this one. It's also something that the big language models know well, and they've seen a lot of examples and they know how to do the extraction. It might be a little bit slower in the creation, but you probably need less passes. If you study the Microsoft one, they do a lot of passes to refine the knowledge graph. This one looks more, it's a slower pass, but you don't need many corrections. And of course, things become easier if you have a predefined ontology, the types and the hierarchy, and you're looking only for this type of extraction. In fact, one of the things that we're working right now is to, you might have seen that there's a lot of companies and projects that they're trying to guide the language model during the decoding to conform to specific format. I think the easiest we've seen is making sure that it's a JSON format or something else. You can enforce other constraints on the decoding side. And this is something that we're working on for the next version to be able to incorporate that.
So like right now, like the big hot thing that I'm seeing, other than like people playing around with RAG systems or knowledge RAGs, is like agentic systems. Are you also seeing like a big movement in terms of like people being more curious on chain of thought or building like an agentic workflow?
Yes, in my opinion, people don't mean the same thing when they talk about agents, and they split them in 2 categories. One is the micro agents, and the other the macro agent systems. Okay, now let's start with this one. The macro agent system is when you create, I don't know, 5, 6, 10, 7 different personas that they're trying to solve a problem. I mentioned before that people have made a whole virtual lab that designs proteins and antibiotics. We want to talk about this work, which we published at NeurIPS, have this common, it's a very common problem. People come to you with a huge schema with thousands of columns and say, I don't really know what I have. And we use a few agents that they collaborate and they create the semantic layer. They basically try to create views that capture concepts. You can think about that as a quick and dirty knowledge graph or ontology over your database. The same way that GraphRap is trying to do that on documents, we do the same thing, but on databases, okay? So that's the macro world, which is great. It takes time. The micro world is what, let's say, DeepSeek is doing or O1 is doing. So people are saying, I have a language model, and that language model needs to fight and answer a question, okay? And it has to be in maybe minutes, seconds. And it does all these cool reinforcement learning style searches like tree search, chain of thought, reflections, generating. If you ever used O1, you can see, or DeepSeek, you can see that. And there's obviously ways of building these micro agents. If you have the language modeling knowledge, you can play with them, and you can even use OpenAI has as an alpha reinforcement learning to train them. Which I would say it's for the more niche, more high-end companies. You need to be quite technical, or you can pick the first solution that I mentioned. But so this is quite exciting, and we see big returns. But I think there are some pitfalls over there and some things that we are neglecting. We like to see the shiny object, and if you want, I can talk about that.
Yeah, I'd be interested in learning a little bit more of that.
We forget that a language model is not all about reasoning. Reasoning is one of the tasks that a language model can do. There's other things, and the most important is like the instruction following, okay? Or the social skills, like empathy and being nice. And of course, it's the whole alignment problem, like being aligned, okay? And I think sometimes people get carried away and I think they rush too quickly to say, oh, it is fantastic at this job, but it's not great at other tasks. Judging and evaluating a language model and having it well balanced, it's not an easy task. And in some cases, you might actually want, so there are cases where we want a smaller and weaker model that can think a lot during inference time and solve reasoning problems. But in other cases, you might want a more sophisticated model that can give you an answer in one shot with decoding. And I think balancing these two is not, we're learning how to do that. In fact, if we want to go back to the elephant in the room with DeepSeek, they claim they did everything with reinforcement learning, which is you just have somebody telling you if your reasoning is right or wrong without giving further feedback. But I think we have more evidence that they used some kind of imitation learning, which is like fine tuning. Like I give you the chain of thought. And there were a lot of people that they actually replicated the experiments and said, if you balance that with some fine tuning, supervised fine tuning or imitation learning, as people call it, with some, go to a bigger language model, you generate the language thought, you fine tune it, and then you do reinforcement learning, you can do it, you can have better results, and you can actually be cheaper, much cheaper. I think there's more for the companies to do in their automation by using the macro agentic systems, and I would focus more on that. You can get some really cool examples. And the coolest thing is that once you do these macro agents, maybe all the data sets, all the conversations that you're generating, maybe you can use them, you can go back and use them as training data for smaller models.
Yeah, I was about to say, if anyone's ever played around with the DeepSeek R1's the model and you go into the thinking part of it, it's hilarious to read it because it honestly reads as if like that model has a very high anxiety. It's okay, the user is asking for this. Do I do this or do I like do this other thing? And it thinks through it. It does it very rapidly, but yeah, if you ever play around with the R1 models at home, you'll see what I'm talking about where
Hmm.
it honestly does look like the model has like anxiety when it's trying to reason through it, but it's trying to reason through it very quickly. But also I think it's just like the way that it's written because it's based on like training data. So what are your thoughts right now on this whole DeepSeek R1 news that broke out like a week and a half ago or something like that? News hit that the R1 model was like cheaper to build. It performed just as well on certain categories. And then like we saw all of the big like players in the AI field, like Nvidia, etc., all their stocks plummeted overnight. I think like Nvidia lost like $500 billion within like a couple hours. What are your thoughts on like these new models that are coming out that are challenging like the big players like OpenAI, Anthropic, even like the manufacturer like Nvidia? What are your thoughts on those?
Yeah, I'm not a stock market expert, but there was some rumor that there was some bubble, and bubbles burst sometimes for irrelevant. Something else can happen that people say, was that important? But it turns out they were already pop, and anything that would touch them, they would pop. So maybe it was a correction. I personally don't get that much anxiety about it for the following reasons. I've seen benchmarks before saying, oh, look at this model, it's much better than the big ones. But let's not forget that the big ones also know a lot of things. Okay, now, so there's several cases where in theory, people say that, oh, it beats that big model in all these benchmarks, but still when I use it, I still prefer one of the big ones. That's it's very hard to. The other thing is that we're not sure yet about the cost. Yes, maybe I'm pretty. If you go to NeurIPS, you will see that, and that NeurIPS actually all this research was happening before DeepSeek R1. There were people that they were showing that if you do a more careful selection of your data and you use several tricks, you can reduce your costs a lot. It was something that we knew because in the beginning there was a race. People saw that give more data and it's going to do better. But we knew that the data wasn't really the best. That happens all the time. Creating better data sets and curating. Take the combustion engine. Like how many directions of improving your car engine existed 100 years ago? You just needed 100 years to explore them. And your car engine is how many times better than something 50 years ago? It just needed time. So it was a matter of time to reduce the cost. We knew that. I don't think that was anything. And again, if you go to research, you will find a lot of interesting ways. If, in fact, one of the talks at NeurIPS was claiming that the scaling curves that we see, if you do a better selection of your data, they can be even steeper. They can be even better. And also the fact that you can do the same with less hardware, it doesn't mean that you can do even more with more hardware. I think DeepSeek didn't prove that. It proved that you can do the same with more hardware. It didn't prove that if you increase the hardware, if someone goes to DeepSeek and give them the hardware that they're not supposed to have, maybe they can do even better. And the same thing, did cell phones or processors stopped becoming better and better once they hit certain milestones? No, they just went further away. I think the best way to see that is the hardware business in other cases. Things that you could do on your computer, now you can do even more on your cell phone. So when we built processors that they could do what the bigger computer would do, we just did more. I think if you ask me, the threat for NVIDIA, it's not DeepSeek. The threat of NVIDIA was something else that I saw at Neurips, which is there is a constant trend to reduce the amount of computation per square millimeter that is useful for neural networks. For example, what is the thing that takes most of the time and most of the energy? It's like floating point multiplication. Like multiplying to floating points takes a lot of transistors in a lot of gates. Now, with the quantization and the lookup tables, it was an excellent presentation from the head of AI of Microsoft Research. I can't remember his name right now. I highly recommend your listeners to view that. Where now with this kind of quantization, now we can do the same thing, but with others and lookup tables. That's already an order of magnitude smaller circuits that can do the same. And then there was a paper that it didn't do language models, but it was getting closer to doing less sophisticated deep learning models with XOR gates, which means that if you can do the same thing with XOR gates, imagine how many operations you can run. I think this is if I were NVIDIA, that's what I would look into more.
For reviewers who want to know more about agentic systems, RAG systems, what's the best route to get in touch with you?
They can go through LinkedIn. I'm about to post, as I said, I spent hundreds of hours going through the material, and I'm going to post videos and slides of this analysis. They can always try to email me. I get a lot of email out there. I think it's easy to find my email if you Google me. So I'll give them that challenge. Or maybe I could say it's nvasil@gmail.com. I'm not afraid of spam because I receive a lot of spam. Try to be creative in your title. And I try to speak in conferences, not as much as I used to do in the past, but I try to post something, let's say, once every month on LinkedIn. I also try to respect the information overload, only if I find something interesting.
And then any last minute tips for our viewers who are curious about building their own knowledge base and want to get started? Is there any cool resources that they can get into right off the bat?
So we posted some videos because we post on the Snowflake Solution Developer Center about how to do that. As I said, it's coming up from us a solution guide of how to build your graph RAG, and we're going to have more sophisticated methods for building neural graphs. I highly recommend studying the Wikidata format and try to see if that solves the problem. Other resources, the problem is that if there was a system that could build your knowledge graph perfectly, I would tell you. It does require a lot of experimentation with your case. So you have to work on your prompting. There's systems like SyncCode and Outline that they help you guide and put restrictions on your output. So if you have a specific ontology, you might be able to, it does convert these constraints to a grammar and helps you do something better. The prompt can always go sideways. And of course, there's always this idea of training your own language model that knows the ontology really well that you're trying to enforce and can have better results.
Thanks so much for being on the show, Nick. And until next time, stay curious.
Thank you. Thank you, Tony, for hosting me.